Is the equation linear? So for each part, we're going to plot some points and sketch the graph and say whether the graph is a straight line. First example, y equal 2x minus 1. So we want to pick some values for x. And usually I like to pick small integers just to make the computation easier. So I picked here -2, -1, 0, 1, and 2. Those will be our x values. And then in the equation y equal 2x minus 1, we can replace x by these numbers. So if x is -2, y is going to be 2 times -2 minus 1. 2 times -2 is -4. -4 minus 1 is -5. If x is -1, y will be 2 times -1 minus 1. I'll do the multiplication first. 2 times -1 is -2. -2 minus 1 is -3. If x is 0, y will be 2 times 0 minus 1. 2 times 0 is 0. 0 minus 1 is -1. If x is 1, y will be 2 times 1 minus 1. 2 times 1 is 2. 2 minus 1 is, 2 minus 1 is 1. If x is 2, y will be 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1 is 3. Okay, so now we have some points, and we can plot the points. The x scale goes left and right. Negative is left, and positive is to the right. The y scale goes left, up and down. Negative is down, and positive is up. Okay, so the first point, x coordinate -2, y coordinate -5. There'll be 2 to the left, down 5. So start at the center, go 2 to the left, and down 5, and put a dot there. And the next point be 1 to the left, down 3. Put a little dot there. And then we have 0 left or right, down 1. And 1 to the right, up 1. And 2 to the right, up 3. And these look like they're all pretty much on the same straight line. If we connect the dots, we'll get the rest of the points on the graph. Okay. So this does appear to be linear. So the graph is a straight line. Okay. So this is it looks linear. It looks like a straight line. Okay. So the equation is probably linear. Okay. Okay. Next example. Y equal x squared minus 3. I'll adjust the light here a little bit. Okay, so again, we want to pick some numbers for x and compute y. And again, usually it works best to pick small integers just to make the computations easier. So I picked -2, -1, 0, 1, and 2. If x is -2, y will be -2 squared minus 3. Exponents come before subtraction. -2 squared, -2 times -2 is 4. 4 minus 3 is 1. If x is -1, y will be -1 squared minus 3. -1 squared, -1 times -1 is 1. 1 minus 3 is -2. If x is 0, y will be 0 squared minus 3. 0 squared, 0 times 0 is 0. 0 minus 3 is -3. If x is 1, y is going to be 1 squared minus 3. 1 squared, 1 times 1 is 1. 1 minus 3 is -2. If x is 2, y will be 2 squared minus 3. 2 squared, 2 times 2 is 4. 4 minus 3 is 1. Okay, so now we have some points. Again, x is left or right, negative is left, positive is right, y is up or down, positive is up, negative is down. Okay. So the first point has x coordinate -2, y coordinate 1. Both from the center, you go 2 to the left, up 1. And you put a little dot there. And next point, 1 to the left, down 2. Put a little dot there. Then we have 0 left or right, down 3. 1 to the right, down 2. 2 to the right up 1. Okay, so these do not seem like they're on a straight line, but anyway, we can connect the dots. You either go left to right or right to left. You want to do it, connect them in order of the x values. This is actually a parabola. If you take Math 161 pre-calculus, you'll study some parabolas in that course. Okay, so this is not this looks like it's not linear. It looks non-linear from the graph. It doesn't look like a straight line. Okay. Okay, so next example. Y equals square root of x minus 1. So again, we want to pick some values for x and compute y. I picked 0, 1, 2, 5, and 10. If x is 0, y is going to be square root of 0 minus 1, square root of negative 1. And that's what's called an imaginary number. In pre-calculus, actually, they do a little bit with imaginary numbers, but in this course, we're mostly working with the real number system. This is not a real number. So we can skip that one. In fact, anything less than 0 that you put in here is also going to be not real. If x is 1, y is square root of 1 minus 1. Square root of 0 is 0 because 0 times 0 gives you 0. If x is 2, y will be square root of 2 minus 1. 2 minus 1 is 1. Square root of 1 is 1 because 1 times 1 is 1. If x is 5, y is going to be square root of 5 minus 1. 5 minus 1 is 4. Square root of 4 is 2 because 2 times 2 is 4. If x is 10, y will be square root of 10 minus 1. 10 minus 1 is 9. Square root of 9 is 3 because 3 times 3 is 9. Okay, so then we can plot these points. The x values go left to right. These are all positive, so we'll go to the right, and the y values are also all positive. That's going to go up. So the first point, we want to skip the 0, but the first point that we're plotting, x coordinate is 1, y coordinate is 0, so that's 1 to the right, up or down 0. Okay, put a dollar dot there, and then next point is 2 to the right, up 1, and then we have 5 to the right, up 2, and 10 to the right, up 3. Okay, so this is maybe not quite as obvious as the last two examples, but this is not a straight line. Okay, it's a little bit curved there. So it's not linear. This is actually a semi-parabola. The example 2 that we just went over was the full parabola. This is a half of a parabola. It is missing the bottom half here. But anyway, it's not linear. Okay, the graph is not a straight line. Now, so we've been using the graph in these last three examples to determine whether the equation is linear or not, but you can actually tell from the equation itself without doing a graph whether it's going to be linear. So if an equation can be written in the form ax plus by equals c for variables x and y and numbers a, b, and c, and if a and b are either a or b or are both are non-zero, then the graph is a straight line and the equation is linear. So let's see if we can decide without graphing whether these are linear or not. So example A, y equals 3 halves x minus 4. It is linear because we can put it in the form of, if we add negative 3 halves x to both sides of the equal sign, we have negative 3 halves x plus 1y equals negative 4. So this is in the form ax plus by equals c. So we can write it in that form, so that's a linear equation. So this part A is linear. Okay. B is also linear. It's x equals negative 1, but we can write this as 1x plus 0y equals -7. Okay, so again, this is a linear equation because you can put it in this form. A or B can be 0, but they can't both be 0. Otherwise, it's in order for it to be linear. So the second example is also linear. Third example is not linear because we have an x to the second power. So this is not linear here. And a third example, also not linear. This time we have an x times a y. You can have a number times x or a number times y, but for linear equations don't have an x times a y. Part E is a linear equation because you can write it as, this is y equals 5, but we can also write it as 0x plus 1y equals 5. So it's in the standard form or the general form for equation for a line. Okay. Part F is not linear because we have no letters. Linear equation has to have at least one letter in it. And part G is also not linear. We have an x to the third power. Part H is linear. Okay, so yeah, this one here is linear. Yeah, dividing by 3 is the same as multiplying by 1/3. So we can write this as 1/3 x plus -5/6 y equals 2. So it's in the form, we can put it in the form ax plus by equals c. Okay, so it's linear. This is not because of the square root symbol, and part J is not because we have x in the denominator. So the linear equations are A, B, E, and H. Okay. So that concludes this presentation.